Well, good morning, everyone. This is Alan Rooks. I'm the editor-in-chief of Manufacturing Engineering Magazine, and we're starting our panel discussion on the implementation of the Industrial Internet of Things, specifically for machine tool monitoring and maintenance. How this is going to work is I'm going to share my screen, and we recorded our main presentation a couple of days ago. After that's complete, all the panelists and I will come back on live, and you'll be able to ask us questions through the Q&A tool at the bottom of your screen. So during the presentation, please feel free to go ahead and enter any questions you have, and we will get to those right after. So what I'm going to do is I will go on mute, and you'll see us all while I'm playing the presentation. So we look forward to seeing you after the presentation. And as I mentioned, please feel free to enter your Q&A at any time in the Q&A box at the bottom of the Zoom. So bear with me while I get things started here. Welcome to SME Smart Shop, an IMTS Spark presentation. I'm your moderator, Alan Rooks, editor-in-chief of Manufacturing Engineering Magazine, which is published by SME. Our topic today is implementation of the IoT for machine tool monitoring and maintenance. In this session, our three industry experts will explore how machine tool monitoring and maintenance has become one of the most practical and useful implementations of the Internet of Things. This session will examine the state of development in sensor-based monitoring and maintenance of machine tools and how manufacturers are using it today. And with that, I'd like to introduce our panel. First up is Guy Parento, Engineering Manager at Methods Machine Tools. Welcome, Guy.
Thank you, Alan. Excited to be here.
We're glad to have you. And Jim Kosmala is Vice President of Engineering at Okuma America, Inc. Good to have you here today, Jim.
Thank you, Alan. It's great to be here.
Well, thank you. And our third panelist is Kanon Shiu, Product and Service Engineer at Chevalier Machinery, Inc. Welcome, Kanon.
Hello, Alan. Happy to be here.
And with that, let's jump into the Q&A. First off, Kanon, I'll kick it to you. How well developed are IoT-based platforms for machine tool monitoring and maintenance?
I think the technology right now that's in the industry is pretty well developed, but every company has their own system that is basically designed for their own machinery, and we need to see how to integrate it between different companies. I feel that most of our companies, we should be working together. Not every machine shop only has one brand of machine, and we should kind of combine our efforts to make it better.
That's great. Thanks for that answer. So, Guy, what's your take on this question?
Well, I have to agree with what Kanon was saying. That is an issue for sure, where there's multiple people, multiple builders that have their own software, and not every company has all the exact same machine or even the exact same control. So that is definitely a challenge for sure. With respect to how well developed they are, I mean, machine monitoring has been around for a good while now. So there's plenty of people that have been doing that and getting as much as they can out of that on-off and continuing to grow with it. But then the next step, I think, is that maintenance. And we're starting to see that become more and more of a factor. But in my opinion, a lot more companies need to step it up more and start to really dive into that machine maintenance part of it. And we'll kind of go from there with it.
Sounds good. Thanks for that answer. So, Jim, how does Okuma look at this?
Certainly I agree with Kanon and Guy. Common language and talk between the machines is important. I think MT Connect takes a big step in that direction. And in Europe, OPC UA, hopefully they merge to a global standard, kind of like Bluetooth. So if we all have the same protocol, all the machines will talk and be integrated and connected in the same IIoT platform more readily. In terms of being developed, certainly like I said, IIoT platforms for machine tool monitoring, they are very functional and developed by today's standards. There's always room for improvement, and I'm sure platforms will be different and much better in the future. But that said, they've been around in various forms for decades. Back in the late 1980s and 90s, you had the early machine tool data solutions, all machine solutions. When the big three were Wonderware, Inillusion, and GE Fanuc, Simplicity and Prophecy. And now today, with modern machine tool controls being designed more and more with connectivity in mind and with more software systems or apps in manufacturing performing tasks that used to be manual, IIoT solutions for machine tool monitoring and maintenance have grown significantly in the past 10 years. The products available have matured quickly. The shift from islands of individuals in the machine tool ecosystem that were pushing connectivity to end users expecting it, it just illustrates, the products in the IIoT offering have value. For example, Okuma, we've had MacMan data, that's our acronym for machine management, on every Okuma machine since 2003, back when we put Okuma's OSP control onto a PC. I mean, it's literally on a PC, an Intel chip running Windows. And so the MacMan data, it has a boatload of data about the machine. It wasn't until 2007 Okuma put it on a network and called it MacMan Net because it was networked MacMan data. So you can see the MacMan data on all the machines, in one place. And of course, I often refer to Deming's statement. He once said, without data, you're just another person with an opinion. And that's what these data collection systems, all of them, all these data collection systems out there, they give you. They give you a lot of data.
That's great. I think, we can all agree that 5-10 years from now, things are going to look a lot different. So, and with that, our next question, we can dive right into kind of the meat of the topic here. What are the key tools that manufacturers and job shops, what do they need in order to start implementing IoT-based machine tool monitoring and maintenance? Kanon, why don't you kick this one off?
So we're finding that our customers and even at our facility is the networking, how to network all these machines together. A lot of the people we set these systems up in, they don't have networking in their machine shops already. They don't have either routers or hard cables wired throughout their facility. So I can sell you a system simple, but it's how do you network it with all your machines and how do you wire it in? And that knowledge and having someone local out there to wire all the factories together basically into the offices. Most of the buildings we're finding is they're wired in the office, but they're not wired in the warehouse. They're not wired on the machine shop. And we really need to help our customers with that.
Yeah, it sounds like there's a lot of challenges still. Guy, is that what you're finding, and what do you see as the key tools?
That's absolutely the case. Most companies don't have a network infrastructure set up for the machine tools themselves. But when customers come to me and ask and they say that they want to try and start developing an IoT solution, I always tell them the best thing you need to do first is create a plan. You need to create a plan. You need to get a sense of purpose of what that plan is going to be, outline your goals. And when doing that, you want to create a sense of scalability. People always get kind of focused in on, oh, this one little thing I want to do, but you need to be able to scale it across all your machines because kind of like we talked about before, customers will say, well, I have this machine that's running this and that's all they care about. But to scale it up, what do you do about this other machine that's not the same thing? You want to be able to kind of adopt it across the entire thing. And then to be successful with it, you need a good internal leader or expert to help advise and continue on that plan and kind of figure out what vendor you want to use to do your remote monitoring and maintenance solution. You also have to have your company internally aligned on we're doing this for this reason. And that means not just getting the front office to be bought in, but you want the entire company to be, because it will fail as soon as the operators don't have buy-in and they don't feel that they're going to think Big Brother's watching them. And so a big goal is to convince everyone this is great for everyone. This is going to improve our quality of working. I'm not just trying to see how many parts you're running, but how can I make them faster and make it easier for you so you're not going all over the place trying to get something together. And then you need management's commitment because it's going to be bumpy. There will be problems, but you need to have a solid champion that forces you guys through that bump and keeps going. Vendors can say, hey, this is really easy to set up, and it is, but there's that one machine was. But once you start to get the whole process involved, it gets really sticky. And the last point I have was I said everyone's involvement, and I would say the number one big problem I find is that companies don't get their IT department involved immediately because once you have their buy-in, you really have a lot more acceptance and a lot more bumps go away because they're all for it.
Yeah, absolutely. Jim, what's your perspective on key tools and how to get this thing going?
Yeah, I think, well, certainly agree with everything Conan and Guy were saying. For us, first and foremost, the machines need to be connected. It's amazing how many machine tools are not connected today. We get a new computer at home. The first thing you do is plug it in the internet. Your machines, you get as much value out of networking them, but it isn't second nature. And the technology for more and more machine tools to be able to do that is increasing rapidly. And there's more benefit to connecting your machine than just machine monitoring and maintenance and data collection. You can also, from an efficiency standpoint, download your NC programs from a server instead of SneakerNet with a guy running around each machine plugging in a USB stick. The machine's network, you can have it send you emails if it has an alarm condition. We have a free app on the Okuma App Store that does that for you. But your machine's got to be connected. And as most of you know, and I mentioned Okuma machines are on a PC, we put Microsoft Teams, for virtual conferencing like this, we put Microsoft Teams on the machine tool. So, distributors or customers, they can share live screens on the machine. They can even let someone remotely take control of our machine to look at, cutting parameters, system variables, the NC program, and so forth. It's really cool, but you can only do it if your machines are connected. So I think number one is we got to start connecting more machines. Um, and second, as the others alluded to, you need a champion, an employee, not only a great machinist, but with a skill set to understand PCs, the PC terminology, and so forth, and manufacturing, so that you can achieve what you want to get out of the system. Some might remember the days where you had an industrial engineer, and I remember those days, walking around with a clipboard and stopwatch and timing things and taking notes, and some of that often led to rudimentary machine monitoring and maintenance. But now IIoT, with your machines connected, you get a lot more visibility into the machines, and it's instant. Without human bias and without the manual labor of going to each machine. But the point is, even back in those old days with the engineer and the clipboard, the engineer just didn't write stuff down and go home. He went back to the office and figured out what it meant, what he wanted to do with it. Same things needed for the IIoT, machine monitoring and maintenance. You can connect the machines and collect the data. That's the easy part. Then you need a champion with the right talent, an engineer or experienced manufacturing employee to decide what to do with the data, how you want it displayed, and how you're going to use that data to make better decisions in manufacturing.
That's a great thought. Yeah, it's plugging in or connecting the machines. That's always a key basic, like making sure your computer's plugged in. So.
Yep.
So we've touched a bit on this next question, but let's get into it a little more deeply. So these tools are out there. People can take advantage of them, but how widespread is the use of these tools? And from your customers who have actually used them, what are some of the lessons learned that new users take advantage of? Kanon, what's the experience at Chevalier?
So, like Jim was saying, is you need someone to interpret the data. I can get you all, you have all the data in front of you, but we're finding a lot of people, they don't know what to do with the data. What does this mean? What does it mean that my spindle is running at like 80 degrees Celsius? What is that good or is that bad? So we also need to educate the customer on how what each of the data means. Is it time for you to change your spindle? Is it time for you to maintenance your machine? It's not only about efficiency, it's about keeping your machine up as well. You can see how many hours are on it, and a lot of people don't know how many hours is good for me to change out my spindle. How long can I have it running before I change out my spindle? Well, you need to see the accuracy. So are you always at high temperatures? Are you always running at a high spindle load? So you need to be able to interpret the data properly, and we're really teaching our customers how, when you get the data, how to interpret it, and that's what a lot of people need to start learning.
Yeah, it sounds like it's an opportunity to help your customers just run their machines better in general, right?
Correct.
Okay. So, Guy, what is methods discovered as you've gotten into this with some of your key customers?
Without a doubt, definitely, we can see the need for a data scientist to actually take the data and start using it. I think any big corporation just they know the value of it, and they immediately get that person to take that role on. But with respect to the tools used, kind of like Kanon was referring to, with respect to the maintenance side of it, we're starting to see builders and customers, as soon as the machine gets on the floor, they start monitoring it. And so while the machine's brand new, in doing the spindle burn-in and everything else, they're recording that data. And so over time, they actually can create a baseline of here's how it's supposed to run. And then I've seen other softwares out there that'll monitor it, and over time they can start to say, hey, this is allowed, a 10% threshold, and it'll actually just monitor it. And once it gets to that level, it'll trigger. Now, a benefit to having a manufacturer piece of software is that they know and can set those limits already into it and say, well, this is my machine and this is what it should be at. So if the spindle gets to this, I need to generate an alarm. Those are great tools that I've seen firsthand, which is really a big saver. But then in terms of monitoring other things too. They're monitoring the different signals in the machine, not just spindle, because that's like the obvious one. It's the things that you don't know are obvious that start to come to light. Downtime or alarms, tracking all that. With respect to the lessons learned, I think a few that have happened where a lot of customers want to just jump into it and just connect everything. And I would say start small, start with a good small core example, because as soon as you connect that machine and you start collecting that data, it is going to be like drinking out of a fire hose, and you will get so much information, you won't know what to do with it. So you need to kind of start it out and kind of just feel it out, and then build that model and then expand upon it. It definitely can be overwhelming, and I've seen a lot of customers have a plan in mind, and it's great to have a plan in mind, but don't be upset with that having to change. Hey, I want to monitor if it's just on and off, but then you might find that they want to monitor this and this, and it's okay to transition to that. But everyone's expectations change as soon as they see all the information they're grabbing drastically.
Yeah, it's also kind of a good selling point. Once people get into it, they discover some of the things they can do, and they get more excited about it.
For sure. What's funny is I don't know many people that once they get it say, yeah, we don't like it. We wish you didn't do it. Most everyone that has it goes, yeah, I don't know what we did without it.
That's great. So Jim, among Okuma customers, how widespread is this? How many customers are doing this, or is there kind of a rough percentage?
How widespread it varies greatly by industry and region, but it's increasing everywhere. Not only is usage increasing, but also the mindset that in the future, those that use data to make better decisions in manufacturing will be displacing those who don't. Lessons learned, I probably have a lot of energy in that area based on our installations of Okuma Connect Plan. Like many things that has come up, expectations are very important in using an IIoT solution for manufacturing and machine tool monitoring. For some reason, some potential users expect to install the data collection system, and then it just makes everything better. It reduces labor, increases uptime, lowers their cost, machine availability, and so forth. And for that, I have a couple analogies. Do your machine tools do that? You just plug in your machine tools and they start making parts that you sell for a profit? It's not quite that simple. You have to get work holding and tooling and material for your machine, keep the material flowing, make sure it's not blocked or starved, and maintenance and so on. Similarly, an IIoT system doesn't just do everything for you once you plug it in. You have to use it to tell you what you're looking for, and working with it like you do with your machine tool to make parts. And that kind of leads to my second analogy. IIoT systems are kind of like an ERP system for your machines. And anyone who's implemented an ERP system knows that you don't just fire up that ERP software and everything works. For ERP systems, you get out of it what you put into it, what screens you develop, what reports you generate out of it, and so forth. So in other words, IIoT solutions for machine monitoring gives you data you can use, data that you need to turn the data into knowledge to make better decisions. Now, it does give you some knowledge like spindle utilization, machine status, machine health, and so forth. But those that use IIoT systems well, they extract that data from a database. So like Okuma's Connect Plan, all the data from it goes into a SQL database. And the more advanced users will extract that data from the database and maybe combine it with data from something else, like say their quality system. And so they'll then combine their quality data with the asset utilization data from Connect Plan, and they'll calculate their OEE and generate reports that show their OEE. Third, and perhaps most important, is Guy alluded to, start small. For some reason, some people don't realize that while they're really familiar with scope creep on projects, scope creep occurs on IIoT implementations. And if it gets too complicated, we've seen efforts die birthing because it's too complicated. And don't discount a simple red, yellow, green until you try it. Red, yellow, green can be very powerful. Not only can production and maintenance guys see every machine's runtime and machine status, maintenance and more all at a glance, but also operators see it too. And they know it's being watched. And by far, most operators, they take pride in being green more so than any kind of big brother paranoia concerns. They get a sense that it matters. And so I always enjoy, we typically see a transition from within the factory workers from reacting to preventing. The guys get a little competitions going too. In the first week or so, they're reacting to yellow and red and maybe pick on some of the guys in some of the areas with less uptime. But in a couple of weeks, and sometimes with the help of area managers or maintenance guys, they start to anticipate, and rather than reacting to red, they remember what happened a couple of times, and they know it's about to happen now. It's about to go red. And so they take measures to fix it, whether it's getting more material or calling the fork truck guy to get more parts there, whatever. But they transition from reacting to preventing. All that's just from red, yellow, green. I like to joke about those winning the lottery strategies that look at percentage increases. If you buy 10 lottery tickets instead of 3, your odds go up this much. And if you buy 20 instead of 10, the percentage increase is even better. The single largest jump is that first lottery ticket. Because you go from 0 to doing something, and red, yellow, green is that first real big step.
That's a great thought. Thank you. So to wrap up our session today, I thought we'd get into what a lot of our viewers would like to hear about, which are real-life examples of how manufacturers and job shops have actually used these monitoring and maintenance tools to improve their operations. So with that, Kanon, what have you found with your customers?
So we implemented the system at our factory to make our parts and to help build our machines. And we're using the data from our plant manager to see what makes it easier. How can we lay out our interface so they can easily find the data they're looking for? Then we can take all that information to our data specialists to analyze the data. So when a customer has this data, they're asking, oh, what do I do with this? So our engineers can come out and we can help them. We can educate them on, okay, this is what you can do with this data. And in turn, the customer will share their data with us. And obviously, in any statistics, the more data you have, the better. So the more customers that share their data with us, and then we can implement that in our system. This works, this doesn't work, this is kind of difficult to get to. We can constantly improve our interface and our system. And some customers even bring up, hey, you should monitor this. Why isn't there a sensor on this part of the machine? And we can learn that, and we can implement that in all future machines.
It's great, yeah. So in real life, it's the partnership that makes the system work.
Correct, yeah. It's the partnership between us and our customers. As long as our customers keep sharing how they feel about our product to us, we can keep improving it. If they tell us something that doesn't work, they need to let us know, because if they keep it to themselves, we'll never know what's not working for them. And we can improve it for the next person or for their next machine.
That's a great point. So Guy, what does the real world look like at Methods?
For real life examples, I'll start with, I found that there are certain customers buying certain machines because of the amount of data that they get out versus other machines. They're beyond just looking at the quality of the parts, and that they're now saying, what can the machine itself give me for information? And these are companies that have already been established in the machine monitoring and have experienced the value of it. So now they're being picky about not only the machine itself, but the control and what they can actually get out of the machine, which I found to be very interesting. In addition to that, for examples, it's interesting. So the machine monitoring possibilities are endless, but one big thing that it pulls from is it gives you that data, and you can start to look at your bottlenecks. Where's your bottlenecks? It's here, it's there, and you can just see what's the choking point. And then what you do is the big important thing is you need to go down on the floor and go look at it, and you look at your data and watch it happen. And an example with a customer was they found that setup time was this exorbitant amount of time. And they found that, just by implementing some lean practices and some, Six Sigma qualities, they said, okay, we'll put setup over here. And now this guy doesn't have to go there. And we just cut our setup time in half. And again, back to the operator, they're happy because now they don't have to walk across the shop. It's all their stuff's right there. It makes their life a lot easier. And my second one is an example I just heard of this morning, actually, which was back to the preventative maintenance, which was they're monitoring all the data and they're looking at, they have two of the same machine, but on one of the machines, they notice they have to do tool offsets a lot more and they have to constantly update it throughout the day, whereas the other one, they don't. And so at the end of the day, this one needed 7 and this one needed 2. And then they extrapolate that and they look at over the course of history and maybe this machine's starting to wear. Maybe we should, get some maintenance on this and clean that up. And those are things that most companies and customers don't think of when they start these processes. But once they start to use it so much, the possibilities are really endless and you can customize it to your own way of working.
Great, that's exciting. So Jim, why don't we wrap up with you and tell us all about some examples that you've seen, some success stories, and how people are using this.
Sure. And I'll open with, rather than giving you Okuma's answer, we surveyed our customers of Okuma Connect plan, and I can share with you basically what they said. Their top 7 responses were, and I'll walk you through and show you some of this. Machine visualization was number 1. All the machines on one screen that they could see, whether they were in the shop or in their office or from home on a PC or on their phone. That machine visualization of all the machines in their layout. Second was utilization tracking. We've talked about asset utilization, mainly spindle utilization. Analyze processing results. Like as I mentioned, you want an open system where you can access the data and do other things with it. SQL is a great platform. Number 4, see machine information from anywhere. Kind of touched on that under visualization, number 1, on your phone when you're not there. Right now during COVID, that's more handy than ever. Number 5, preventative and predictive maintenance. I can touch on that. Number 6 was maximize machine uptime. Like in the book, The Goal, you don't try to optimize one thing, you do them all simultaneously. And number 7, time-sensitive installation and easy serviceability. So again, those are our end users' answers, not Okuma's. And Okuma, we're very pleased that most of them are very much aligned with our design intent of an IIoT machine monitoring and data collection system. So with that, I can maybe briefly share what some of that looks like. It's not on a real customer system, but it is a real live action current machines running in Okuma's Aerospace Center of Excellence. We use the tool ourselves as well. And so you can quickly see if the machine is red, yellow, or green. Again, that's that first big step. It's also kind of a big step on their whole overall data journey. It's like Lay's potato chips. Once you try one, you got to have more. Once they get the red, yellow, green, they want this, that, and the other thing. And so this will show you basically, what the status of the machines are. Now, again, this is our Aerospace Center of Excellence, so we don't have a whole lot of downtime, and we keep up on our maintenance. It's at Okuma, but you talk about maintenance monitoring an IoT system. When the maintenance begins to approach at the 75% mark, and by that I mean if your maintenance period is 100 hours, at 75 hours, you'll get this little yellow icon next to the machine, right next to the red, yellow, green traffic light. And it'll tell you the maintenance period is, at 75% by showing that little yellow icon, and it turns red at 100%. So again, it's a very simple rudimentary tool that customers have used, said, wow, a lot of times they don't even know. So it's preloaded with I'll give you a quick look at a machine here. It's preloaded with the machine's maintenance manual data. So you go to the maintenance tab, and you can see nothing's red or yellow, or you'd see the little icon. But all these items in the maintenance tab are in the maintenance manual. Now you can add some additional ones as well if you want to. Say you bought a third-party mist collector and you want to make sure they clean it every 40 hours or 80 hours. So you can input that and add more maintenance items to it, and it'll continue to monitor them. So I think tools like that are going to be more and more useful, more and more prevalent. Part of the things that, as they say, start to separate the people that use data from the people that don't use the data, and it's going to give people competitive advantage. And the connectivity we've talked about, you can see. So not only do we have, that's our Aerospace Center of Excellence. This is our quick shop where we actually work on our own machines to make parts, spare parts, or anything a customer needs real quick. We've got a couple of old Okuma Captain Lays here. And this is just a JPEG you can drop down, and these little traffic lights you can drag and drop, and you're up and running. So I think making it easy to connect machines is important. We've talked a little bit about the variety of things we can connect. This is our Partners in Think facility about half a mile down the road from us. These machines, FANUC machines, FANUC control connects just as quick as Okuma and gets just as much data. MT Connect, this machine is controlled on MT Connect just to show how we do it. It's super easy and it's free. The MT Connect adapter is free on the Okuma App Store, and you can get it for any other machine as well, any major brand machines. And MT Connect plugs in immediately to Connect plans, so that's, I think, a step in that direction of connecting everyone's, having a universal language. So I think those are all kind of the important steps in making IIoT solutions more readily available and usable. So with that, all of those things tie back to what our Connect Plan survey customers were asking for. We have installations of our Connect Plan IIoT solution everywhere from very large global manufacturers to small 10 to 20 machine, job shops. And out of respect for them, we can't freely name names in a public discussion. I guess one we can is Dysinger. They absolutely love their system, and we've got a public statement from them that our marketing department will be releasing soon. We like to talk to them first on a case-by-case basis. By all means, we take customers to see our current installations regularly. So anyone interested in seeing a system, we'd size them up with a similar size existing customer, and then talk to that existing end user first about their openness for a site visit. And I commented on what the survey said. I don't have time to go into details on each of them and how they improved operations. But one of my favorites, just as an example, is we had one customer that improved their scheduling process by using real, actual measured cycle times from the IIoT system instead of using design or simulation cycle times for scheduling. They looked at, real, not just cycle times, but real run times of programs versus simulation of their run times, actual production throughput numbers, and by applying those real world numbers to their scheduling process, their throughput went up. And of course, data collection, was automatic. It wasn't a person with a clipboard and stopwatch. And so again, that's just one example from someone that specifically wanted to improve their scheduling, and they went out and used the system, the tool, to collect the data to do just that.
Well, that's terrific. Well, I think we got, in a short time, we covered a lot of ground here. And gentlemen, I'd like to thank you for your excellent insight into this topic. And to our audience, please bear with us as we transition into the Q&A session. All right, looks like we're back. So I'll ask our panelists to unmute their videos and their audios. And we will get into the Q&A here. Let's see. Oh, Guy, can you hear me? Jim? Are you guys on?
Yes,
Loud and clear.
yes, sir.
Okay, good. All right, great. And Kanon, you're on as well?
Yes.
Great. Okay. All right. I'm going to check our Q&A and hang on one second while I pull that up. All right. I think I'm rolling here. Kanon, why don't we start with you? Do only new machines work with the IIoT software that you described, or do I need to replace all the machines in my shop to get IIoT software?
So you can integrate the older machines as well, depending on the controller. If the older machine has like MT Connect, or it has the ability to output the OPC UA, then you can connect it to our system. If you have, like, let's say a machine from the 80s that doesn't have that, that's not available for connection. Here at Chevalier, any of our Model 3s of our CNC smart grinders can be connected. All the Fanuc controllers on our machines can be connected as long as it's the OI controller. And even the new machines on our automatic machines, you can connect our 84s. You can connect them in to the system and monitor even an automatic machine, not just CNC.
Great, thanks for that answer. Jim, this next one's for you. There's a lot of talk about artificial intelligence. Can AI play a role in IIoT machine monitoring solutions?
Yes, absolutely. I think, we're in the dawn of the artificial intelligence age, and AI feeds on data. So IIoT systems that collect data, they feed the beast. And so as more IIoT data collection systems are deployed, the market for AI and the use cases for AI will increase. A number of builders, including Okuma, are already beginning to incorporate AI in various forms in and around our machines. I can't speak appropriately about other builders, but I can about Okuma. At Okuma, we have 3 different applications of AI. One is on our IIoT system, Connect Plan. I can share a little bit more about that, but the other 2 are AI that's on the machine tool itself, spindle AI and ball screw AI for the feed axes. Those are on the machine, so not directly part of this panel discussion, but there is another IMTS Spark event right after this focused on discussing our AI implementations. But on the AI algorithm in our IIoT Connect Plan data collection system, it learns how you use your machine tool to predict that ever elusive yellow machine state, when it's idle, wondering, is it really in setup, or is it waiting for material, or is it waiting for the operator? Connect Plan AI looks at all the system variables, in OSP, the parameters, the machine state, the current OSP screen that the machine is on, and other information to automatically determine why that machine is sitting there idle. And if it's wrong and you correct it, the next time the AI will spot that in similar scenarios, learning your operations. So AI algorithms like that will become more and more widespread, because not only do they become the smartest guy in your plant before you know it, but they don't go anywhere. The AI algorithm doesn't leave for another job or family reasons or whatever. Some plants suffer from turnover when the guy that knew everything left. With the AI in your IIoT system, that plant knowledge is retained.
That's great. Sounds like a brave new world here.
Oh, yeah.
So, Guy, this is kind of a nuts and bolts question. What sort of hardware infrastructure does a shop need before implementing anything that's IIoT related?
with respect to hardware, infrastructure-wise, you need to look at some companies have a very broad, giant network with multiple layers and multiple separate networks all in their building, and then they have building to building, and then maybe even state to state because they have a huge system. In those, usually you're not going to have an issue implementing the software to get it connected because the machines already are, but you're going to have a lot of hurdles with trying to get all the remote locations under one umbrella of software. Now, if you don't have an infrastructure, like we've talked about throughout the cast, was that you can go and get it networked up. But an alternative as well is some manufacturers offer these edge devices with a SIM card in it, just like a cell phone. And so if you have a good cell phone area, service-wise, you can just drop these in and kind of try that out as well. It's simple. There's not a lot of setup required because it's kind of automatic. It's the easy button. It's not the cheapest, but if you want to get a machine up and running very quickly, you can rely on that. You can then access all that data from any internet-capable device. You log into the cloud and you're able to see it. So that's a very easy, simple solution for a customer that maybe wants to avoid talking to IT, or they want to just get their feet wet and experience it without investing in a huge network. That's definitely a choice for them as well.
Oh, that's great. That's a great answer. Kanon, back to you, and a question about the software. Is the software easy to use, hard to use? What's been your customers' experience with that?
So most customers think our software is pretty easy to use, and I've used several other softwares. We all kind of typically, I think every company had the same idea. Jim was alluding to the red, yellow, green. All the software I've used, the different softwares, all use the red, yellow, green light to tell you if your machine is alarmed, working, or idle. And it's very straightforward. All the interfaces are easy to use, and you can find what you need quickly. It's just everybody places their tabs in different areas, and when you click through, they're all just slightly different. But I find like all the softwares, at least the ones I've used, are very simple and very upfront.
Terrific. So, Jim, this is going back to the beginning. The opening question was, how developed are IIoT machine monitoring and maintenance solutions today? Where do you think IIoT solutions are heading in the future?
Yes, I think the future, it'll bring a continued drive towards turning data into knowledge. Today we have more and more tools to collect large amounts of data from our machine tools and other equipment. Now we have to look for ways and develop more ways to turn that data into knowledge that helps make better decisions in manufacturing. I believe the big three impacts to improvements in manufacturing that we'll see movement on in the future are what I refer to as the technology trilogy. They are AI, digital twin, and 5G. Those three work off of each other. As I mentioned earlier, IIoT systems fuel the beast of AI. AI is fueled by data, and 5G is going to provide more and more bandwidth to exponentially increase the availability of data, thereby providing rich resources to feed the AI. In digital twin, when that starts moving into applying digital twin to people's PLM on their product and applying AI, they'll be optimizing designs faster than people can.
Yeah, it's going to be an interesting future for everybody. So anytime we're sharing information, obviously cybersecurity is a big problem. So this question addresses that. And Guy, question is, are there inherent cybersecurity risks for integrating this type of technology?
Short answer, absolutely there are. It's whenever you connect anything into a network, you need to be thinking cybersecurity to some level. What I recommend is that you consult with your IT department to start getting them along with it. They're going to know certain things that you have no idea about with respect to firewalls and the software they have running in the background, and making sure that that doesn't interfere with the software you're trying to run. In addition to that, I would also say that when you're trying to go and find who you're going to use, whose software you're going to use, ask them that question and see what they have to say about it, and kind of hear them out, and make that be a thing that you use to decide if you're going to use them or not. Like, do they give you that confidence that they've done this before and they know all about that cybersecurity? There are many customers out there. If you're in aerospace or if you have an ITAR customer, how do you handle that? That's a whole nother level. So you definitely want to approach that and bring that up and get the manufacturers to give that information back to you.
That's a great way to start. So let's see, back to Kanon. This is kind of related to the previous question. What are the risks associated with IIoT machine monitoring?
So like Guy was saying, there are some cybersecurity risks, but in terms of physical risks, like will it bring down my machine? It will not. Plugging in your machine to the software, it just monitors it. It will not bring down your machine. It will not stop production. As long as everybody is on board, like was mentioned previously. Once everybody's on board, everybody's learning how to use it properly, there's no risk to stopping your job or stopping your work on the machine. Can't really think of, the only one I can really think of is like if someone was learning how to use the system and they accidentally misclick and they change a parameter. But that's an instance where your inside office people are not on board with your operators. So everybody needs to be on board. Everybody needs to be working together when these softwares are installed.
Sounds like a good plan. So this question is for Jim. Among the various IIoT machine monitoring solutions available today, are there some general similarities and differences among them to consider when you're looking at pursuing an IIoT solution?
Yeah. And like Kanon was saying, there's a lot of similarities in terms of what they do. And there's a number of good IIoT monitoring packages out there. In fact, 3 of them are partners with Okuma, Predator, Freedom IoT, which was formerly Freedom eLog, and Primo, who also incorporates AI. And there's other offerings out there like Machine Metrics and Chevalier's solutions, and so a number of them. And like Kanon said, they all do very similar things, maybe some in different ways. They all look at machine status, machine health, uptime, availability, and so forth. So to compare the similarities and differences, I think it helps to consider, 3 main categories: the hardware, the software, and the way it accesses and displays the data that it's collecting. So for example, on the hardware side, does the data, is it storing the data on an on-premise server or is it cloud-based? Pros and cons to both. Some prefer the on-premise server because they can put their hands on it, figuratively and literally, and control security. Whereas cloud-based, some have concerns about their data being out there on the cloud, physically residing on some unknown server somewhere. And so again, pros and cons. Pro on cloud-based is you don't have to worry about a server, configuring your on-premise server. So then you move into the software side. And there's kind of 2 areas to look at in software. First, if it's an on-premise server, is your server on Linux, like many of them are, or is it Windows 10 server? Linux has advantages if you've got an IT guy that knows Linux. If not, pretty much everyone's comfortable with Windows 10, especially with the new securities in Windows 10. And then separate from the server in the software side, how is the data managed and displayed? For example, some use proprietary software and the data is locked down and it works in their system, and their screens do what they do and that's it. Whereas, for example, the Okuma Connect Plan system, our system is open, and by that I mean it is browser-based. We use Chrome, but Internet Explorer will work, and Edge will work also, and any Firefox, whatever. And so you, with your browser, you browse to a site on the server, and you see everything that I showed previously. And all that data, so open is Chrome. The other open component is it's stored on an SQL, SQL Express database. So users can access that data anytime they want to do whatever they want with it. It's an SQL database. They can do SQL queries or reports or tie data to their ERP system, whatever. And third, I mentioned the way the data is stored and displayed. Some prefer to see as much data as possible squeezed into one screen so they can draw the most conclusions possible without changing screens. Maybe you can tell I'm not a huge fan of that. Our screens start with that bird's eye view of the whole plant, showing the machines and the proper layout, and really only displaying red, yellow, green on each machine. It's simple, quick view of everything. You can always drill down on any machine if you want to just by clicking on it. And also many of our users really like that bird's eye overview when they do tours of their shop. It's like a visualization of their shop. They start the tour showing, that bird's eye map, if you will, saying, hey, we're standing right here right now. We're going to walk over here to the gears line and then over here to the shafts line and so forth. So those kinds of things, can be real helpful. And when they give tours to people that they're, maybe bidding on a job for, they also see, okay, these guys got all their machines connected and they're collecting data and moving in the right direction. So I think all those things that are key to look at when choosing a system. A lot of good systems out there, but considerations are what feels best for your shop in terms of hardware, software, and the way it accesses and displays the data that it's collecting.
Well, great. Well, I have to apologize to everyone for my doorbell going off in the middle of our presentation here, but one of the drawbacks of working from home. So we're actually getting close to the top of the hour. So Guy, why don't you wrap it up with this last question, which is, do all machine controls allow for the same data to be pulled for them? That sounds like a good one to get into.
Very quick answer is absolutely not. Not all controls are created equal. We alluded to it a little bit. What you'll find is that some manufacturers are really good at it and already allow for a lot of data to be processed. And some say they can do it, but requires you to go do some extra work and add some extra hardware and software to make those things capable. And so you need to be aware of that. So you want to be talking about that with whoever software you're looking for and kind of discuss that information with them. They might say, oh yeah, we've connected to this all the time, but then you find out once they go to do it that you need to invest another $3,000 or $4,000 just to do it. Other machines, I can speak for the Fanucs. The Fanucs all talk very, very well to them. I think anything from like the mid-90s on is more than capable of getting you a boatload of information. The newer ones, of course, are going to have more. But in addition to that, you definitely want to consider asking your contractor or your manufacturer that you're looking at using, not can they connect, because everyone is going to say, yes, I can. But you really want to say, have they connected? I understand you might find that no one's connected to your machine, but at least if you find out that they have, it can give you a little bit of peace of mind that they've done that before or something similar. So kind of hold them accountable and try and force them to give you more information.
Well, it's terrific. And with that, we're finishing right on time. So I'd like to thank Guy, Jim, Kanon. Really appreciate all your expert help here today. I thought we covered a lot of ground. Our thanks also to IMTS for sponsoring this session. And we appreciate our viewers tuning in. So have a good afternoon, everybody.
Thank you for having us, Alan. Bye-bye.
Thank you, Alan.
Thank you.
Our pleasure.